Happy Monday. This is Mr. Chad Bayhue again with yet another Khan Academy video for you. Okay, so today we look at determine the domain of functions with Khan Academy. And as in my other videos, I'm just going to show you a couple of examples directly from Khan Academy. Maybe you'll get the exact same problems that I'm showing you. Maybe they'll be slightly different, but if you watch the video, you'll definitely, understand how to do it. So the instructions, or sorry, the title is Determine the Domain of Functions. And I want you just to understand that the main goal of this is to understand that a function's domain consists of all values of x that return a real number value for y. So if you were to substitute in for x a -2, for instance, what would be the output? What would be the value of y, or the output? So I would substitute a -2 in, and I would have -2 divided by -2 minus 7. And if I simplify this using order of operations, I'm going to simplify the denominator. I'm going to end up with -2 over -2 minus 7 is -9. And a negative divided by a negative is positive. So I would get 2/9. So is -2 a part of the domain? Well, a function's domain consists of all values of x that return a real number value for y. So is this output 2/9 a real number? Well, this is our real number system, and our real number system consists of natural, whole, integer, rational, and irrational numbers. So 2/9 is a rational number. It is two numbers divided by each other. And so yes, it is a real number. So -2 should be part of the domain. If I look at the answer choices, what is the domain of f? Choose one answer. A, B, C, D, and E all begin with all real values of x, all real values of x. And then some of them start to say, well, such that x is not this, or such that x is greater than or equal to this, or x is not equal to that. So it's saying most every single number is going to be a part of the domain. But maybe there's one or an infinite number of numbers that isn't part of the domain. So what I thought I would do to help you understand this is to remind you of two things. One is from our previous lesson, which I called Khan Academy number 1, I think. Or maybe it was Khan Academy number 2. I think it was Khan Academy number 2. I'm just going to shrink that up a little bit. Okay. And that is, there are some things that are not real numbers, such as if you have the square root of a negative number, that's not going to be a real number. So if there was any x value I could put in that would give us an output that was the square root of a negative number, we would know we could not have that be a part of the domain. Also, if we created something that had 0 in the denominator of a fraction, we know that that's not going to be a real number either. That's called an undefined expression. So if it's -4/0 or 1/0 or 9/0, then certainly we're not going to have a real value that's an output there. So I'm going to try a couple of test numbers. I'm going to now say, okay, well, what if I input a 3? If I say f of 3, well, it's going to be my output. So if I put a 3 in, I get 3 over 3 minus 7. Simplify that using order operations is 3 over 3 minus 7 is -4. And I get another fraction, -3/4. -3/4 is a rational number. So that's fine. What happens if I try to substitute in 7? Something different's gonna happen. I can't resist spoiling. Okay, this is where we see that not everything works all the time. So f of 7 goes in, and we end up with 7 over 7 minus 7. And I simplify that to become 7 over 0. And 7 over 0 does not work. This is one of those things that we saw in what I called Khan Academy 2. So with this thought in mind, 7 is not a value of x that returns a real number for y. 7 happens to be the only number in this particular problem that will not work. And so I'm going to choose all real values of x, real meaning the real number system, such that x is not 7. So every single number we can think of over here, with the exception of this one number, 7, which gives us a 0 in the denominator. So that is our answer for what is the domain of f here. Now there's another way to look at it, and the other way to look at it is to actually just graph f of x equals x divided by x minus 7, and I've done that. So on the next slide, what you're going to see is a Desmos picture of x divided by x minus 7. And when you look at the Desmos picture, what you're going to notice is that the function has this red part that goes here, and it has another red part that goes here. And we can actually see something that helps us understand what is part of the domain and what is not. So let's remember that a domain is all x values. So we're looking at the x-axis, and I'm thinking, is there a value at negative 10? Yes. The input of f of negative 10 gives me an output. So does negative 9, negative 8, negative 7, negative 6, negative 5, and so on. All of my x values, x value of 0 returns something. F of 0 would be 0 over 0 minus 7, which is the same thing as 0 over 7, and 0 parts of 7 is 0. So you put a 0 in, you get a 0 out. It works there. But what happens is we start to get close to this number, 5, 6, 7. And what you're going to notice is that right at the point where the x value on the x-axis is 7, there is no y value. That we get what's called an asymptote here. That we're going to get infinitely close to 7, but there'll be no y value output. Same thing over here. As my x values go from 10 has an output, 9 has an output, 8 has an output, but 7 has again this asymptote. So our graph shows us that we have x values that go to negative infinity, but as the x value gets close to 7, something happens, something weird happens, there's no output. And then x value goes to positive infinity, and as it gets close to 7 on this side, something happens. We have an asymptote. There is this imaginary dotted line that I cannot make straight because I am not good with this little tablet. That was horrible. This imaginary do not touch me line at 7. I'm going to get rid of that. It stings my eyes. Okay, so there's just another way to look at it through Desmos. All right, so what I'm going to do now is I'm going to show you a couple of different examples from Determine the Domain of a Function Khan Academy 3. Here's one. F of x equals x plus 1 quantity squared. So if I look at x plus 1 quantity squared, I realize that this function right here, oh, I'm still on that dotted line thing. Okay, is a parabola. That Khan Academy gave me a quadratic function. And so here's what I'm thinking about. I'm thinking about all of my x values on the number line. And I'm thinking, is there an output at 0? Yep, the output is 1. Is there an output at 2? Yep, looks like the output is 1, 2, 3, 4. Is there an output at 3? There sure is. Is there an output at 4? Yeah, it's probably right about here. Is there an output at 5? Well, yeah, it's probably way up there somewhere. I can't really see it. But what I can imagine is that this parabola keeps growing and growing and growing and keeps going that way. So even though I don't see it on my graph, that there is some output at 6, at 7, at 8, at 10, all the way out to positive infinity, that there is an output. If I were to enter in, say, 100, if I were to go all the way out to x is 100, and I would say, is there an output at f of 100? Well, f of 100 would be 100 plus 1 squared. 101 squared is a really big number. I don't have a clue what it is, but it's a real number. It's just going to be a really big real number. Likewise, in the negative direction, as I am thinking about, is there a value of the output at -5? Well, I don't see it, but I can predict it's going to be right about there. And at -6, it's going to be right around there somewhere. And in fact, everything out to negative infinity is going to have an output that is a real number. When we square numbers, we don't leave the real number system. We say that the real numbers are closed under squaring. And what I mean by closed is, move my big head. Look at our real number system, that any number that is a real number, when we square it, is going to stay a real number, that we can't somehow leap out of the real number system by squaring. Okay, so with that thought in mind, put my big head back, I'm going to say that this is all real numbers satisfy the domain. The domain of x plus 1 squared, or really, hint, hint, any parabola. Any parabola is always going to have an all real number value of x as its domain. Okay, so here's our next one. F of x equals the square root of -2x. So I put that into Desmos, and Desmos gave me this picture back out. And as I look at this picture, I notice that all of the values go in this direction. I'm almost tracing that, almost, but not quite. And my x values of like x is 1, x is 2, they don't have any information here. So that's interesting. X is 1, x is 2, there's no information. There is no part of this function that has an x value of 1 or an x value of 2. Well, I wonder why. Let me go ahead and try that. Let me see what happens when I put in an x value of 1. F of 1 equals the square root of -2 times 1, which equals -2 times 1, -2. Oh, I see. F of 1 returns to me the square root of a negative number. You cannot square root a negative number and stay in the real number system. So that means there is no information out here. My domain has to be 0 to negative infinity. So how do I say that? I would say something like all real numbers such that x is less than or equal to 0. All of these x values are less than or equal to 0. So that would be my answer. Anything out here, like 2, if I were to try f of 2, I would get the square root of -2 times 2, which is the square root of -4. I cannot get these square roots of negatives to be real numbers. So again, like, move big head, the main idea of this entire Khan Academy is all values of x that return a real number value of y are going to be in the domain of the function. And I have to remember that some things are not real numbers. Square roots of negatives, not real numbers. If I ever have a 0 in the denominator, not a real number. Okay, I'm going to quickly go through a couple of more now that I've repeated myself repeatedly. Here we go, and let's go fast. Okay, I put g of x equals 5 minus 2x into Desmos. It returned a line. You can see that all that they did in Khan Academy was sort of change around our basic y equals mx plus b. If I wanted to write this as y equals mx plus b, I could have written this as y equals -2x plus 5. So I'm starting at 5, I'm going down 2 over 1, and I can see that this is just a line. Okay, so what's my domain of a line? What x values can I have for a line? Well, my x value of 5 returns something. My x value of 7 returns something. Even though I can't see it, if I substitute in a 10, I'm going to get a number back out. It's going to be a real number. So my x values are actually all real numbers. Lines can have any input and give you a real number output. Parabolas and lines, all real numbers. That's a little secret for you. If it looks like a parabola, if it looks like a line, it's going to have an all real number domain. Okay, so now here's a bunch of them, right? Let's go quick. Let's just take a look at these and burn through them. Okay, I see an x plus 2 in the denominator. I'm thinking, what makes 0? Well, if x equals -2, I'm going to have a -2 plus 2. I'm going to get a 0 in there. So this is no bueno. We cannot have -2. So all real values of x, such that x is not equal to -2. That's what it is. Over here, there is a real number in the denominator. There's an x up here. What happens if I made x equal to -6? Is that okay? Can I have a -6 plus 6? Yeah, 0 over 2, that's 0. That's a real number. So even though there's a fraction going on, even though it kind of looks like this is going to be fine. If you plug that into Desmos, you would see that there's no gaps in it, that this is still all real numbers. Any number that you put into that's a real number is going to return a real number as well. Okay, we look at this one real quick and we think, oh, that looks a lot like this one. If I put a 5 in there, I'm going to get a 4 over 0. I can't have that. So I'm going to say it's all real numbers, but x cannot be 5. All right, I think that's all of the ones I put on here. That's it. So hopefully that helps you understand Khan Academy. I'm calling it number 3, determine the domain of a function. See ya.